We have one question from the chapter Maxima Minima. The question says find the maximum area of an isosceles triangle which is inscribed in a ellipse. This is the general equation of an ellipse with the vertex at the origin at one end. Sorry, we are talking about the vertex here of the triangle, right? Not of the ellipse, with vertex at one end of the major axis. So now let's say, for example, if I make a Cartesian plane, this may be the Cartesian plane, and now I'm going to make one ellipse. As you can see from the equation, that the major axis is along the x-axis. Now we have to make one triangle here, isosceles triangle, where the vertex of this triangle is on the major axis, let's say from here. Let's say if I join these 2 points. Perfect. And from this side, all right. Now we got an isosceles triangle, and as it is mentioned that, let's say, this is the vertex. I took this point as, say, A. Let's say make it P here. This is Q, and this is R. And I took this point as, say, M. This has to be 90° here. We have to maximize the area of the triangle. What else you should know that any point, the point P has to be A0. And we should know that any point on the ellipse is in the form of his x coordinate is A cos theta and y coordinate is B sin theta. Further, we can say that this R is on the fourth quadrant. So its x coordinate will be positive only and y coordinate will be minus B sin theta. Now, in order to find the area of this triangle, you can figure out that it is half base into height is what we are going to use here. So the area, for example, should be half. Base I can see is Q R and the altitude is cm. Now, if I have to find out the measure of QR, the length of QR, as you can see, this QR from here to here, it's a y vertical, right? Vertical length, which is denoted by y coordinate. It is B sin theta. And this side here, this point, Rm, is minus B sin theta. But as you know that in case of a distance is always positive. So we'll be taking positive. So this is A sin theta plus A sin theta. That is 2 times, sorry, not A sin theta, it's B sin theta plus B sin theta. So it will be 2 times B sin theta. And if we talk about the base is what? Base is PM. And this being the origin, what you should know again that this part is OM, and OM is the coordinate of M is what? A cos theta. That means from center to this point M, its distance is A cos theta. And from here to here, what you know, it is A. So we can now say that this length will be this length. Once again, we're talking about this length, this PM. PN can be obtained as OP minus OM. That is OP minus OM. And what is OP? OP is A. That's clear from the figure. And what is OM? Which is minus is there, and OM is A cos theta. So we can say, if I take A common, we'll get A common 1 minus cos theta. Right. So now we can place the value here. That is half into QR. QR length is obtained from here. That is 2B sin theta. And CM is A times 1 minus cos theta. So we got this. That is the base and the altitude. And now we'll differentiate so as to get the point of extreme and then apply double derivative test to prove that the maximum area is obtained at some value of theta. Now I can see that here 2 and 2 get cancelled, and if I rearrange, I can write this area as A from here and another B from here, that is AB sine theta times 1 minus cos theta. Now I'll differentiate it, say A dash, AB being coefficient. I'll first apply product rule. So sine theta derivative is cos theta, and I'll keep 1 minus cos theta as it is. Then we'll give a plus sign. This time sine theta should come as it is. And 1 minus cos theta is what? 0 minus sine theta. That is, derivative of minus cos theta is sine theta. So 0 minus sine theta is sine. So instead of writing another sine theta, I may write sine square theta here. Now, we'll not open the bracket, realizing the fact that we have to equate with 0 and factorize. So why first opening the bracket and then factorizing? Let's factorize at this place only. I'm writing sine square theta, square is over here. Sine square theta as 1 minus cos square theta, right? 1 minus cos square theta, I can write 1 minus cos theta plus 1 plus cos theta to reduce the number of steps involved in solving. Well, this came to my mind because when I see 1 minus cos theta over here, that's why I wrote 1 minus sine square theta as 1 minus cos square theta, which is this. Now, what we have here, I can see we can take common, right? That's the reason. So I'm going to take 1 minus cos theta as common. So this is 1 minus cos theta taken common. We are left with a cos theta over here, 1 plus this. So this is this plus this is what? 2 cos theta plus 1. So this is 2 cos theta plus 1, or you may write 1 plus cos 2 theta, that's all same. 1 plus cos 2 cos theta. Now for maxima or minima, A dash has to be equated with 0. So what you can see that if I equate with 0, this is not going to make a significance. This equated with 0 will get cos theta as 1. We'll get cos theta is equal to 1, or when this is equated with 0, we'll get cos theta as minus 1 by 2. Now, what you need to figure out here that if I place cos theta as 1, right, over here, so 1 minus 1 is what? 0. So this will become 0. 0 multiplied by any number is 0. So the area is 0. As you know, area cannot be 0. So we'll have to discard this value. So we'll say it is not possible. This is not possible. So clearly cos theta is this. But then we also have to get the sine theta. For that, I'm going to use the property of triangle. Cos is base, ignoring this sign, base upon hypotenuse. So by Pythagoras theorem, 4 minus 1, 3 under root 3. This is under root 3. So I can say that if cos theta is this, then sine theta is going to be perpendicular upon hypotenuse. Now I'm going to take a positive values for the reason I told you the area has to be positive here. Now we'll do second order derivative in order to, second order derivative test is what I'm going to do. So I need to make some space here. Yes, we had enough space to do the second order derivative. Now for second order derivative, I'm going to differentiate, say, from here. So it is a double dash, a double dash is AB. This is AB here. Oh, this is fine, or this is fine. This will be better. So from here only, I'm going to apply product rule. So the differentiation of 1 minus cos theta is only sine theta. Then I'll keep this 1 plus 2 sine theta, 2 cos theta, sorry, 2 cos theta as it is. Then I should give a plus sign here. This time I'll keep 1 minus cos theta as it is. What's that gone? 1 minus cos theta as it is. And the differentiation of this would give you what? Minus 2 sine theta. Now we'll find a double dash at by placing this sine theta as this and cos theta. So if we do so, AP sine theta is root 3 by 2, 1 plus 2 times of this is what? Minus half. So I should write minus 1. But this is 2 multiplied by minus half is minus 1. That will come as 0 plus 1 minus minus half is plus half. And we have this minus sign over here. So minus root 3 by 2. So 2 and 2 get cancelled, right? So 2 and 2 will get cancelled. So we'll get what? Root 3 only. Minus root 3. 2 multiplied by minus 2 multiplied by this, right? Is minus root 3. Now if I proceed forward, this was root 3. Now if I proceed forward, this say AB. Now this is part is 0 and there is a 0 over here. And then this is a plus sign. This is what? This is 3 by 2 into minus root 3. Well, clearly it is less than 0. So we'll say that hence maxima or maximum at sine theta is equal to root 3 by 2 and cos theta is equal to minus half. So once we got this, now we can find out the area. That's what they have asked for. So finding the area. Where is the area? I can see the area of the triangle is this one. It's being the area of the triangle, that is, I marked it. So area of the triangle is what? AB sine theta, which is root 3 by 2 into 1 minus cos theta. So 1 minus minus half, that is plus half. So this is 3 by 2. So that is 3 in the numerator. So it's, I'm getting 3 from here, right? 3 multiplied by root 3. So that is 3 root 3 times by 2, which is 4 AB. So this is root 3 by, this is 3 by 2 when multiplied by this is 3 root 3 by 4. Now I should write square unit. This is the area of the maximum area, right, of the isosceles triangle.